Welcome to Ask an Expert, where a technical product expert answers questions from our customers. Hello, this is John Appleson, Marketing Manager with Pepperl+Fuchs. So welcome, Tracy, and thanks for being here.
Hi, John. Thanks for asking me.
The first question asked about a sensor that is able to detect people in a specific area at a museum. The area of detection is 96 inches by 96 inches, and the sensor would be approximately 96 inches off the floor. The customer is wondering if an IR area scanner would work. Tracy, what solution can we offer to this customer?
Well, the area this customer wants to monitor is pretty big. It's about 8 feet by 8 feet. For the detection of people in this area, my choice would be a motion sensor from the RMS series. This sensor uses radar technology to cover an area larger than most infrared or ultrasonic devices.
Tracy, this customer wants to know if the CJ40 FP-A2P1 comes with a cable or a connector. He also wonders if this sensor is potted and whether it could withstand installation in a vacuumized vessel. Can you shed some light on this?
Sure. First, I'll address the part about the sensor's connection. It doesn't have a cable. It doesn't have a connector. This particular model has a terminal compartment, which means it's designed for hard wiring. We do also have a version of this sensor. It has a different model number that has a pre-wired M12 connector, and that version would require a mating cord set for connection. The customer's second question has to do with the sensor's physical construction. The electronics in our capacitive and inductive sensors are potted, and their housings can withstand low pressure and vacuum levels without damage to the sensor. Customers can find details by referring to the standard listed on this product's datasheet.
We received a call from a customer wondering how to teach the UB100 F77 E2 V31, if a cable is used in the process, and how he would go about it. Would you please clear this up?
The instructions for using the external teach input on this sensor can be found on the sensor's datasheet. The input is on pin 2 of the connector, and it's used to set the switch point of the sensor, which is the point beyond which target objects will not activate the sensor's output. This customer may also be asking about the optional push-button programming unit that can be used between the sensor and the power supply, which can provide the same function as connecting and disconnecting the teach input wire during programming. For this particular model, the push-button programmer is model UB-PROG4-V31.
In this next application, the customer wants to know if he can use an incremental rotary encoder with 550 pulses per revolution in place of the same encoder with 100 pulses per revolution, or PPR. Tracy, what can you suggest?
The pulses per revolution, or PPR, indicates the maximum resolution of an encoder. You can use a higher resolution encoder, for example, with 550 PPR, as a replacement for a lower resolution one, such as 100 PPR, as long as there's a provision in your pulse counter for a division by, in this case, 5.5 to be calculated. In this case, the customer's encoder used to output 100 pulses per revolution, and if he replaces it with the 550 PPR model, he'll have to divide the count in order to have it mean the same rotational movement that it did with the lower resolution encoder.
In his final question, a customer has an outdoor humid environment and wants to use an inductive sensor and would like to know the life expectancy when used under such conditions. He also wants to know if the target material needs to be within a certain range around the diameter of the sensor in order to be detected. Tracy, can you please shed some light on these questions?
First, I'll answer the life expectancy question. The sensor this customer is asking about is an inductive sensor with a waterproof IP rating and a wide operating temperature range of -40 to +85 C. The sensor electronics have no moving parts and should last decades or more as long as the sensor is operated according to the specifications listed on its datasheet. The attached cable and wiring for the sensor should be protected from the weather using an appropriate conduit. The customer's second question has to do with where the target needs to be in order to be detected by this sensor. The sensing field is generated from the sensor's face, and any target metal that enters this field when moving toward the sensor axially or across the sensing face laterally will be detected at a certain point based on the properties of the target. These properties include size, shape, and material. The best way to visualize this is using a response curve that we have for inductive sensors in the intro section of our catalog. This is a document that I often send to customers who are asking this question.
Well, that concludes this segment of Ask an Expert. I want to thank Tracy for joining me today and thank our audience as well. For additional information, here are 5 easy ways to connect with us.